This will be for the con assignment arc length. And all of these angle measurements will be in degrees. So an arc is a piece or portion of the circumference of the circle. So if you notice this part in red right here, this curve that travels from point A to point B, that is considered an arc. Okay, that's basically a portion of the circumference. You can think of like the crust on a slice of pizza. So the arc length would be the actual distance from point A to point B traveling along this curve. So if you were to label an angle in here, this is the center of the circle O, and we can call this angle theta. Okay, that's a Greek letter that represents angle measurement. So the angle of the circle, the central angle, determines what portion or percentage the arc length is of the entire circumference. Okay, and as a result, we can set up a ratio and proportion between the angles and the actual arc length. All right, so as far as the central angle is concerned, the portion is just this Greek letter theta. All right, so that's in the numerator. And once around the whole circle in degrees is going to be 360. Now, as far as the arc length is concerned, it is usually represented by the letter S. And of course, the distance around the whole circle is represented by the letter C for circumference. All right, so S stands for arc length, C is circumference, and this is the ratio and proportion we'll be using throughout the con exercise. All right, so it says a circle has a radius of 3. An arc in this circle has a central angle of 20 degrees. What is the length of the arc? All right, let's take a look. So we are looking for this length right here, from this point to this point right here, traveling along the curve of the circle. All right, so from our ratio and proportion, we have theta divided by 360, and that equals S divided by C. All right, the central angle theta is this angle in here. Okay, they gave it to us in the diagram in the write-up. That's 20 degrees in place of theta. That's divided by 360. S is the arc length, and C is the circumference, which we can easily find. All right, we know the formula for circumference is 2 times pi times r. All right, it was given in the write-up, and also we can see it right here that the radius r is 3, going from here to here. So we're plugging in place of r, that's going to be 2 times pi times 3. And of course, 2 times 3 is just 6. And we're going to leave pi as is. Okay, the reason we're doing that is because it said to enter an exact answer in terms of pi or use 3.14. It's better to just leave it. Okay, so in place of C, we calculated C to be 6 pi. In place of C, I'm going to write 6 pi. That's the circumference or distance around. Solving for S, S is divided by 6 pi. The opposite is times 6 pi. So we do that to both sides. Okay, on the right-hand side, it cancels. On the left, 360 divided by 6 is just 60. And 20 divided by 60 is 1/3. Right? 60 divided by 20 is 3. And this right here is just 1. So it's 1/3, but it's times pi. So you can write it as 1/3 pi, or you can just write pi over 3. That's the same thing. When the pi is out front, it's still in the numerator. That's the same thing. All right, let's see. So just click inside the box, and you can click on the pi symbol, or you can actually type pi, and it will give you pi. Click slash, and then 3. Okay, so I wrote pi over 3, just like my answer. All right, it says the circle has circumference 18, and the arc has a 120-degree central angle. All right, let's take a look. And they want to know the length of the arc. All right. So same ratio and proportion, theta over 360 is going to equal S over C. All right. So theta is the central angle right here. That's 120 in place of theta. Divided by 360. S, the arc length, is what we're looking for. It's going to be the length of this curve. So we don't have it. And C is the circumference. They gave it to us in the write-up, and they wrote right here that it's 18 all the way around the circle. All right, solving for S, the opposite of dividing by 18 is multiplying both sides by 18. And it cancels here. You can probably just do this on the calculator, but I know 36 divided by 18 is 2. So 360 divided by 18 is 20. 120 divided by 20 is 6. So the arc length is just 6. All right, so click inside the box and type 6. All right, a circle has circumference 12. Its arc length is 11. What is the central angle in degrees? Let's see. All right, so same ratio and proportion, theta divided by 360 equals S divided by C. All right, so this part in pink, the dashed line, is the actual arc. So the central angle goes all the way around, almost all the way around from there to there. So that's going to be our central angle, theta. Okay, it's going to be close to 360, but a little bit less because this part is missing. So we're solving for theta divided by 360. It said in the write-up that arc length S was 11. And it said the circumference C was 12. All right. The opposite of dividing by 360 is times 360 on both sides. Cancels here. 36 divided by 12 is 3, and we have a 0, so that's just 30. And 11 times 30, that's going to be 330. So you can use a calculator if you want, or reduce fractions, or a combination of both. But it's going to be 330. So that answer makes sense. We said it would be close to 360, but not quite. All right, one more. Circle has radius 3. The arc has a central angle of 340. What is the length of the arc? All right, let's see. Theta divided by 360 equals S over C. Okay, so this part in pink, almost all the way around, is our arc. Okay, and this angle here is the central angle theta. So that's 340 divided by 360. S is the arc length. That's what we're looking for. And the circumference C we can calculate. We know the circumference is 2 times pi times r. That's going to be 2 times pi. And the radius r is 3. You can see it on the diagram and the write-up. So that's times 3. And of course, 2 times 3 is just 6. And we still have pi. Okay? So make it in terms of pi. In other words, just leave the pi alone. So the circumference C is 6 pi. You plug it in right here. Okay, solving for S. The opposite of dividing by 6 pi is multiplying by 6 pi. It cancels here on the right. 360 divided by 6, that is just 60. 340 divided by 60, let's see. Divide top and bottom by 10, you lose the 0. And then 34 divided by 6, they're both even. 34 over 2 is 17. 6 over 2 is 3. And we still have the pi. Can't reduce that any further. You can put the pi in the numerator or you can put it out front. That's the same thing. All right. So 17, click on pi right here or type pi, click slash, and then 3. 17 pi over 3. All right, so you use this ratio when finding arc length and your measurements are in degrees.